Welcome to the DIY Honda Garage channel. DTC P0238 refers to a malfunction in the turbocharger boost sensor circuit, indicating high voltage in this system. The turbocharger boost sensor plays a pivotal role in measuring the boost pressure supplied by the turbocharger, enabling the engine control unit, ECU, to optimize performance and fuel efficiency. This component is typically found mounted on or near the turbocharger assembly, connected to the engine's powertrain control module, PCM. When high voltage is detected, it threatens smooth engine operation, and if left unresolved, can lead to a cascade of performance issues. The root of this error code can lie in several areas, including faulty wiring or a malfunctioning sensor. It is crucial to follow a systematic troubleshooting approach when addressing such DTCs to ensure that the underlying issues are accurately identified and repaired. The turbocharger boost sensor is integral to the vehicle's torque and performance because it gauges the boost pressure generated by the turbocharger. Its precise location is generally close to the turbocharger unit itself, where it can effectively measure the pressure output. This sensor sends voltage signals to the powertrain control module, PCM, to indicate the boost levels, expected to remain below a specific threshold during normal operating conditions. However, if the voltage exceeds 4.49 volts, the DTC P0238 is triggered, indicating a potential fault in the sensor circuit. Understanding the functions and location of this component is critical for effective diagnostics. Poor connections or degraded wiring can often contribute to this fault, emphasizing the need for thorough circuit checks during troubleshooting. Several factors can contribute to the triggering of DTC P0238. One of the primary causes is a faulty turbocharger boost sensor itself, which may malfunction due to internal failures or manufacturing defects. Poor connections, whether loose terminals or corroded connectors at the sensor or the PCM, can also result in an unstable signal, leading to erroneous voltage readings. Additionally, any damage to the wiring harness connected to the turbocharger boost sensor can further exacerbate the issue, leading to interruptions in the signal sent back to the PCM. It's essential to inspect both the sensor and its associated wiring to determine the root cause of the fault. A detailed check of the mechanical and electrical components involved can pin down the underlying issues. Addressing these possible causes will be vital in resolving the error code. The symptoms arising from DTC P0238 may manifest in various performance-related concerns. Drivers may experience noticeable engine performance issues, such as sluggish acceleration or power loss, as the sensor's malfunction can affect overall engine responsiveness. As the device fails to report the correct boost levels, fuel efficiency can also take a hit. The engine may consume more fuel than necessary due to improper fuel-to-air mixture ratios. Additionally, the check engine light will likely illuminate on the dashboard, signaling that the vehicle management system has detected a fault. Understanding these symptoms helps drivers identify performance concerns early, prompting timely diagnostics and repairs. Addressing the DTC promptly is key to maintaining the vehicle's long-term reliability. The first step in troubleshooting DTC P0238 involves verifying the problem effectively by turning the vehicle to the on mode. This action powers the vehicle's electronic systems without starting the engine, allowing for diagnostic checks. Next, use the Honda Diagnostics System, HDS, to check the boost pressure sensor parameters. Specifically, observe the voltage reading from the TC boost pressure sensor. It should not exceed 4.49 volts under normal conditions. If the readings match this threshold value, the failure can be confirmed as present. However, if the condition does not match the threshold, document the findings, as there may be an intermittent fault, possibly due to poor connections or loose terminals that require further inspection. Reproducing the failure under identical conditions can yield vital insights into the underlying issue, ensuring accurate diagnosis. In the second step, turn the vehicle to the off position and disconnect the Turbocharger Boost Sensor 3P connector to begin evaluating the sensor. Once disconnected, you will need to connect terminals A and B with a jumper wire. This technique serves to bypass the sensor temporarily, helping to isolate the issue. After establishing the jumper connection, turn the vehicle back to the on mode. The HDS should once again be utilized to check the TC boost pressure sensor readings. If the voltage exceeds 4.49 volts, this indicates that the issue lies within the sensor itself, prompting further steps for sensor replacement. On the other hand, if the readings are still outside the expected range, the troubleshooting progresses to assess additional components in the circuit. This systematic evaluation allows you to pinpoint the exact cause of the malfunction effectively. Step 3 involves turning the vehicle back to the off position before proceeding to remove the jumper wire from the Turbocharger Boost Sensor 3P connector. Once this is done, the key should be turned to the on mode again. At this point, it's crucial to measure the voltage between test points 1 and 2, specifically with the Turbocharger Boost Sensor 3P connector disconnected. Test point 1 corresponds to terminal number 1 of the sensor connector, while test point 2 refers to terminal number 3. Ideally, the voltage observed should be approximately 5.0 V. If this voltage level is confirmed, the diagnostic troubleshooting can move to the following step. However, if the readings are incorrect, further investigations into the SG2 line circuitry should take place. This step ensures that the communication between the boost sensor and the PCM is intact. For step 4, begin with the vehicle turned off to ensure safety while performing checks. The SCS line should be jumped, allowing the system to prepare for electrical testing. After waiting for more than a minute, disconnect the PCM connector E, ADP, to gain access for continuity tests. The objective here is to measure continuity between test point 1, which is terminal number 1 of the Turbocharger Boost Sensor 3P connector, and test point 2, terminal number 2, 78 of the PCM connector. If continuity exists, it indicates the SG2 wire is in good condition, allowing for further checks or repairs to be addressed. Conversely, should continuity fail, it will necessitate repairs to correct any open circuit faults detected in the SG2 wiring. Ensuring reliable signals is essential for the PCM to function correctly. The final troubleshooting step mirrors the previous continuity checks but focuses on the P3 line instead. Begin with the vehicle off for safety and jump the SCS line to set the system. After waiting for a minute, remove the PCM connector E, ADP, to facilitate access for testing. Check for continuity between test point 1, which is terminal number 2 of the Turbocharger Boost Sensor 3P connector, and test point 2, terminal number 57 of the PCM connector. A confirming continuity suggests that the P3 wire is functioning correctly. If continuity is absent, identifying and repairing an open in the P3 wire between the PCM and the sensor will be necessary. Through this meticulous process, any disruptions in the electrical pathway can be effectively solved, restoring function. Once troubleshooting and repairs are complete, it is critical to conduct a final verification before considering the issue resolved. This process starts with thoroughly inspecting all connections made during repairs, ensuring that there is no risk of poor connectivity affecting the sensor operation. Following this, a test drive of the vehicle is essential to confirm the functionality under normal operating conditions, allowing you to monitor for symptoms while the system is loaded. After satisfying performance on the test drive, clear any stored DTCs using the diagnostic scanner or HDS, resetting the vehicle's monitoring system and preparing it for future driving. Finally, conducting one last scan post-clearance to confirm that there are no re-emerging DTCs related to the Turbocharger Boost Sensor is the final step to ensure a successful repair. Preventative maintenance plays a significant role in avoiding future recurrence of DTC P0238. Regular inspections of the wiring harnesses connected to the Turbocharger Boost Sensor can easily mitigate risks of wear or damage. Keeping connections clean and free from corrosion will ensure reliable sensor performance and prompt communication with the PCM. Furthermore, routinely monitoring the vehicle's boost performance while on the road can lead to early diagnostics of problems, allowing for informed decisions regarding future repairs. These practices can contribute to the longevity of both the turbocharger system and overall vehicle performance. Adopting these preventative measures will save time and costs associated with extensive repairs down the line. In conclusion, understanding the roles of components involved in the DTC P0238 error code is essential for efficient troubleshooting. The Turbocharger Boost Sensor, located near the turbocharger, is critical for performance management, and any high voltage readings must be addressed promptly. Adhering to a systematic approach during troubleshooting ensures that issues are resolved effectively, with steps designed to isolate faults in the sensor or wiring. Regular maintenance practices can prevent such errors from reoccurring and promote the overall health of the engine and its components. By fostering knowledge in these areas, vehicle owners can achieve a deeper understanding of their car's systems, ensuring better performance and longevity. Please like and subscribe to the channel. See you next time.